I'll be presenting about the ratio test, covering some rough proofs of the outcomes. First, let's remind ourselves of what a series is. A series is a sequence derived from another sequence by summing up the first n terms. In this presentation, I'll be using b sub n to represent the series and a sub n to represent the sequence being summed. The ratio test can be used on a series to infer whether it converges using the ratio of consecutive terms in the summed sequence. Note that this test only works if the limit of this ratio as n approaches infinity is defined. There are three cases, depending on whether the magnitude of the limit L is less than, greater than, or equal to 1. If L is less than 1, the series is convergent. Considering a strictly positive version of the summed sequence, we can identify some big N where the elements decrease by an arbitrary ratio less than 1. All terms thereafter will be smaller than those in a geometric series with the aforementioned ratio. Since the terms prior to n have a finite sum, and the series from the remaining terms is convergent since it is smaller than a geometric series, the total series must be convergent as well. If L is greater than 1, the series is divergent. Eventually, the sum terms must all grow in magnitude, implying that they are all greater than some term a sub n. These sum terms are actually precisely the difference between consecutive terms in the series. Choosing an epsilon smaller than the term a sub n, we find that the difference between terms in the series will always be larger than it. Thus, the series diverges. If L is equal to 1, we can identify a pair of examples that display both convergence and divergence. A simple pair of such examples are series derived from the sequences of inverse squares and inverses. The inverse squares add up to pi squared over 6 and converge. The inverses diverge. Since the limit of the ratio is equal to 1 in both cases, but we have two different outcomes, we cannot use the limit of the ratio to determine convergence in this case. Thus, we have shown for the three cases of L the conclusion one can draw about the series. Thank you.